0, we can classify the addresses of the ports A, B, and C, which is like if it is 00, then it goes to port A. So in this case, it is 80H because 1, then all others are 0. So 1, 2, 3, 4, it is 0, and 1, 2, 3, 4, it is 8. So 80H. Similarly, if A0 and A1 is 0, 1, then it becomes 81H because all the others here are the same. A7 is 1 and all the others are 0. 1, 0, when A1 and A0 is 82H, and when it is 1, 1, then there is a register which is a control register which we had seen, that goes to the control register. That addressing goes to the control register. And we had also discussed about the control word. Okay, this is where we were, and we had some issues here. So I will start from this control word part. Okay. Okay, we were discussing the control word. So how is the control word coming? We saw there. Anybody else? Ask everybody to uh, join fast. Okay, so we had bits here, D7. Let me see if I can make it simpler to remember. D6, D5, 4, 3, 2, 1, D0. Okay, so what we have is we have modes. We have seen that there was one BSR mode and there was input output mode. Okay, and in input output mode we had mode 0, mode 1, mode 2. Okay, these are nothing but the different ways in which you can program the peripheral. Okay, so then first this D7 bit, uh, okay, this first D7 bit, if it is 0 or if it is 1, it can be two things. So it will select your mode. If it is 0, then it is the BSR mode. Okay, and if it is 1, then it is input output mode. This is the input output mode. So the D7 bit will discuss the mode. From the D7 bit we will get the mode, whether it is a BSR mode or whether it is a input output mode. Now for port A, this D5 and D6 are for port A. Okay, now BSR is only for port C. BSR mode does not involve port A and port B. We will see. Now this port A, okay, port A and port B can be designed for the input output mode. So if it is 0, 0, it is mode 0 for port A. It is not mod, it is mode 0. If it is 0, 1, it is mode 1. If it is 1 and it can be X, that means it can be 0 or 1, it is mode 2. So from port D6 and D5 together, we can get the status of port A, whether it is operating in mode 0, mode 1 or mode 2. Then here, if it is 1 or 0, again it is deals with port A. This bit also deals with port A. So it can be 1 or it can be 0, right? If it is 1, then it is input. And if it is 0, then it is output. So if it is like, if D4 is 1, then port A is in the input mode. If the D4 bit is in 0, then the port A is in the output mode. Okay, so this is all that 1, 0 is saying in which mode it is operating. In in which mode it is operating. Okay, then what is the D3? The D3 is your port C upper, that is used with your port A. Port C upper. Okay, C upper, that is your PC7 to PC4. Okay, we saw that it is used in 2 bits. So if it is again 1 or if it is again 0, that means this is or input or this is output mode. Okay, this much is clear. How this
Ma'am,
one
can you explain the last point of D3?
D C3 we just
D3,
spoke.
D3.
D C3 we just spoke. Where is it? Okay. We said that there are 4 ports, 3 A, B, and C. So the lower goes with B and the upper goes with A. The 8 bits from the 8 bits of C, C0 to C3 is with B. Okay, for other operations. We will see what operations they are. And for PC4 to PC7, they are generally grouped with A whenever needed. Okay, so this bit deals with the upper. This bit deals with the upper. Let me try to write it properly. Okay, so this is PC4 to PC7. This is the upper C upper group. Okay, that is how the nomenclature goes. So this part deals totally with the port A and port C upper. Then what is this? This goes with the group B or the port B or the B group. So what is this? Again, if it is 0 or 1. If it is 0, then it is mode 0. And if it is 1, it is mode 1. Correct? If it is 0, it is mode 0. If it is 1, it is mode 1. If it is 1 or 0, for B it is. Okay? For B it is input or this is output. Okay? And this is this PC3, PC0. So C lower. This is the C lower. So if it is 1 or 0. So it is input or it is output. This much is clear how the control word is going. So this nomenclature is followed for the whole thing wherever we see it. Correct. So let us see one example if we are able to. I'll okay. So now let us see one small example. The question is identify the port addresses. Okay, this is A and this is the what is the B part? It is saying identify mode 0 control word. Identify mode 0 control word if port A and CU is input port and port B and CL is output port. So I have configured it in such a way, I will give you the diagram, small diagram here. This is my peripheral, okay, 8255A, this is my 8255A. So here I have, I'm using A15, okay, uh, or I'm using uh, this is my chip select A8. Then there are many other lines here which I'm not discussing. This is my A0, A1, A0, read. These are the control signals, okay, right? And this is my reset. This is my reset out. Okay. So my port A is here. Port A. Yeah, PA0 to PA7. Here I have my port B. PB0 to PB7 and my CU upper and C lower. That means PC0 to PC3, PC7, PC4. These are my ports. So these two I want to configure as the input port, and this bottom part I want to configure as the output port. So whatever, I will connect my output devices at the output port, say a printer or anything. At the input port, I will connect a keyboard or any kind of other input device that I want to connect the peripheral. Okay. So then what will be my port address? Can you say port address like we discussed? You do it yourself. I will not do it. I will just show you the slide. These slides I've shared with you. Okay. So this is how you will discuss the port address. Okay, so you will find out what is the value. All the others you take 0. Okay, here. So now you can find out the port address from there, from this problem. So for port address, we have already discussed in class. So you please do it yourself in class. Do it yourself. And then how we are going to give the control word. That is what we want to know here. So we have D7, D6, D5. And let us see this what will be the mode here. In the mode 0 we will say. Okay, so we will take it in mode 0. D5, D4 mode, so it will be 1. Okay, so D5 and D6 will be 0 0 because it is mode 0. D4 will be 1 because we have made it 1. We have given port A as input. CU upper is also input, so this will also be 1. Okay. D2 will be 0. B port 0 is mode 0. D1 is output, so it will be 0, and CU lower is 0. So this is your control word for the operation. This is the for the said operation. The control word is this. Easy. So if my control word is like this, that means my 8255A is configured to work like this in mode 0, input and output. Okay, this is fine. So we had seen what was mode 0. This also we had discussed last time. Mode 0, the port A and port B are used as two simple input output ports. Okay, and port C is used as two 4-bit ports, CU upper and CU lower, like we saw in the example. And the features are that the outputs are latched, inputs are not latched. That means inputs can come, outputs will take time. And here there is no handshake or interrupt capability. So there is no handshaking taking place here. What is handshaking? We will discuss when we are discussing mode 1. Now the second thing that we want to see is the BSR mode. BSR mode is, it is the bit set reset mode. Okay, bit set reset mode. So what is this? It deals only with port C. This deals with port C, and it sets or resets the bits. It will set or reset the bit, set or reset the bit for writing appropriate control word. Correct? So here no port A and no port B. We will see. Okay. So then how is the bit set reset done? D7, D6, D5, D4, D3, D2, D1, D0. Okay. So here if it will be 0. So then this is the BSR mode like we saw in the last. Okay. These three we don't need. These are irrelevant for us. Okay. Not used and generally 0. Generally 0 and these are not used. These three. We are interested only in D3, D2 and D1. How? These three will do the bit select. This 3, because here we are having 8, D0 to D7, so we need only 3 bits to select. So if it is 0, 0, 0, it is bit 0, 0, 0, 1, it is bit 1, 0, 1, 0, it is bit 2, 0, 1, 1, it is bit 3, 1, 0, 0, it is bit 4, 1, 0, 1, bit 5, 0, 1, 1, 1, 0, it is bit 6, and 1, 1, 1, it is bit 7. So by setting these 3 bits, we can get which one is the desired bit that we want to set. If it is 1, it is a set command. So by putting either 1 or 0, we are actually programming the whole peripheral. Okay. So we are seeing what is happening inside the peripheral. So if you go into the programming aspects of the 8085 in detail, then these things you will be able to do. Okay. In the BSR mode, individual port C can be used for application such as switching on off. Okay. Port C can be used for switching on off applications. Here port A and port B are not used in this bit set reset mode. Okay. So then can we write?
Ma'am, but D2 and D1 are of port B, right?
No, that is for your mode 1. See, we were for mode 1. Firstly, we have to see if it is 0 or 1, D7. For mode 1, we have to have that 1. Control word 1. Control word 1. See, here we had this was 1 because it was our input output mode. We discussed that there are two modes, bit set reset mode or input output mode. So this bit D7 is used. If it is 0, if bit D7 is 0, then it is bit set reset mode, already decided, nothing to be done. If it is 1, it is input output mode. So when I am configuring my 8255A as to how the ports should function, the first thing is when I did mode 0, then I put it in 1, D7 1, because it was mode 1, input output mode. Clear?
Okay, ma'am. Yes, ma'am.
It is clear. And here I am putting, because I want to do it in a bit set reset mode, what I am doing is first bit I am putting 0 here. So your D7 bit is deciding which mode. After that, all this is taking place. Okay, only when it is 0, D7, only then can you program all D3, D2 and D1 this way. If it is 1, then you cannot program it like this. Correct? So, say, can we take one or two example? For BSR mode, write the control word to set bit PC5 and reset bit PC6. Can we write that? It is simple. So this is the BSR mode. So first this will go. So these three I don't need, and I need to set. Okay, I am putting here set PC5. Okay. So how am I doing? I have to write 5. How do I write 5? 1, 0, 1. Right. And this is we are setting. So set is 1. Right. Set was 1. So this is my control word for the setting of bit PC5 in the BSR mode. We will set that bit PC5. So if you are putting a time delay or you are switching on and off, say you can write a program that when my PC5 in the BSR mode is in the set state, then this LED will glow. Okay, at the output port you have a LED, say. Okay, I'm just giving a rough example. So if my the condition is if my bit PC5 is in set, then in that condition the LED will go. Okay, or if it is reset, then the LED will be switched off. So you can program it. You know what is the operation? We saw it is for switching. So how can we do switching here? So the outputs we can switch on and off. There are some other kinds of switching depending on where we are using the microprocessor. We can switch it on and off. And then if I am resetting PC6, so again it is bit set reset mode. So this 4 will not be this thing, and 6 I am putting, and it is reset, so I will put it to 0. So this is how you can put the control words. So once you have decided, okay, I will there is an example here. Write a subroutine to set bit PC7 and PC3 and reset them after 10 milliseconds. Okay, so you can depending on that the on off operation will take place. So you can put a delay, of 10 milliseconds, and then you can program, and you will set and then again reset. So the output will go on and off, on and off. Okay, that is how you will be able to do the programming part. If you are doing it in this assembly language programming or in your machine language programming, if you are doing, that is how you are supposed to do it. Okay. So the BSR will only affect your 1 bit in port C. When you are setting this, so only it will affect, once you are doing this operation, it will affect only 1 bit in port C is affected at one time. So either you can do PC5 or you can do PC6 or 4, 3, 2, 1. It does not affect the control word, it does not affect the input output mode. It does not affect input output mode. So basically, if you're doing it for the bit set reset mode, the input output mode is not being disturbed. Only your this timing and all you are able to change with the this thing. And this is written in the control register. All the control words are written in the control register. We saw these programmable peripheral devices, they have control registers. And why? Because then we can write these control words in the control register, and we are able to program it in a so suppose there is a temperature sensor, okay, and for the temperature sensor we use an analog to digital converter for port A. This is just for our understanding, okay. And we have a fan and a heater uh, connected to as an input output device to this port A. Then we can design the 8255 in such a way that these devices operate along with the 8255. So you can control the operations of these temperature sensors, the fans and the heaters, everything you can use, you can control using this microprocessor. So you need to, if it is an input output, you put the port A in mode 0. If it is, if you need to program, um, just 1 second. Mm, just give me 1 second, okay? Yes. Uh, so many things you can program along with this microprocessor. This is the example BS. Okay, now we want to see a new concept, that is the handshaking. What is handshaking and why is it needed? What and why? Okay, what is handshaking and why is it needed? See how it is generally connected. So here is your MPU. I think it will make the picture a little clear. There is a MPU, that is your 8085 MPU, microprocessor unit, okay? And you have a programmable device, interfacing device. You have a programmable interfacing device here, okay. And here you have a peripheral. You have a peripheral. Peripheral. Say it is a keyboard. So now, why we need a programmable interfacing device? Because we can connect a keyboard here, we can connect a mouse here, we can connect some monitor here, we can connect some LEDs there, we can connect a heater, we can connect a fan, we can connect anything. So this programmable device, what does it do? It helps us design its output ports in such a way that we can use it as an interface, we can use it to control, we can use to control a time, we can create a delay in the operation. Like in your bit set reset mode, you can create a delay depending on whether you are setting or resetting, right? So that is why we need this programmable interface device. Otherwise, every time we have connected one or two, then again we need another MPU. If we have a different set of operation, then we need to take out that whole MPU and everything and go away, bring another set, which will connect a monitor. Again, if we need to connect something else, say like we saw a water heater or a fan or something else, then again we need to change the whole set. So that is not feasible option. What we need is the programmable interfacing device. Okay. Now, the microprocessor unit, it works in
So,
its
ma'am,
response time. Yes.
here in this case, we are programming this programmable interfacing device or APU.
MPU we are not programming. We are programming only this eight. We are studying 8255. Yeah. So this 8255A is your interfacing device here, the programmable interface. Okay. So you have your input port ABC.
Ma'am,
Yes. Yes.
that means through the programmable interface device, we are reprogramming the MPU to work with different peripherals, right?
Yes. We are connecting different types of peripherals with the MPU, so that the MPU can process. Because your programming device is basically whether it is an input or an output. That is all we are programming, right? But all your arithmetic, logic, operation, and everything is taking place in the MPU. It is not taking place in the 8255A. We have not seen any ALU, or we have not seen a accumulator or anything in the 8255A. If at all any operation has to be done, anything has to be done, it has to be done in the MPU. This interface is just a programmable interface. So we are able to design the ports or program the ports in such a way that we are able to connect different kinds of peripheral devices, if I can put it that way. Okay. Because here we did not study, there was no ALU, there was no nothing. Okay, see, here there was nothing. There is only your connecting, it is only your supply, and how you are selecting this 8255A. That is why this chip select A0 A1, because there also you need to identify the address. Any port or any memory location has to have an address, and only then if that address is identified, only then the signals will go. So A0 A1 and chip select is only used to identify, okay, I am going to 8255A, this 82, if there are 4 8255As, so which 8255A it will go, you can identify, okay, with that address that you are generating. Otherwise, there is only a read write, there is only read write and a chip select and supply. Whereas in case of 8085, we had address latch enable, we had this, we had that, we had so many kinds of stack pointer, program counter, and whatnot we had. So all arithmetic logic operations are taking place in your MPU. It is not taking place here. It is, you are only programming it to interface it with the this thing. So suppose then it is an input. Suppose I want to, okay, what I was saying, the MPU, its response time is in microsecond. Okay. So it is very fast. Your MPU response time is very fast. It is, but this keyboard is not as fast as MPU. So its response time may be in millisecond. Response time, your keyboard, you're pressing S, you're pressing Q, R. So it is in the range of millisecond. So see, your microprocessor is very, very fast, but your interfacing device is very, very slow. So then there is a mismatch in the speed. And because there is a mismatch, there can be data loss. Data loss. How data loss will happen? The microprocessor wants the 1010 very fast, but the keyboard is not able to supply that 10. So the microprocessor might read wrong. Okay, when there is no data, the microprocessor will read some kind of data, because the keyboard is not, he's a very slow, in a group of friends, one friend is very fast and the other friend is very slow, and you are all running. So you have to take your slowest friend along with you. Otherwise, the group will not become fast if it is a group game. So similarly here also, because all of them have to do that task at the same time. Otherwise, the task will not be done. Therefore, they need the handshaking signal. The handshake is needed to understand whether this peripheral is ready to supply the next bit, or it is ready to do the next operation. Otherwise the MPU has to wait. So here the interrupt we had studied, okay, this interrupt comes into function. Because of this interrupt capability, what will happen? By interrupting, the device will tell the MPU, okay, now I am ready. I will interrupt and say, okay, friend, now I am ready. I will give you the next data. So that is why this handshaking signal is important. In mode 0, we did not have handshaking, but in mode 1, we will see there is handshaking. So then suppose if it is a data input with handshake, suppose now we will discuss data input with handshake. How does the data input with handshake happen? Now, what will happen? The peripheral will put a data. The peripheral has a data and it wants to give a data. So it will take one data and put it here. And then it will send a signal STB, which is the strobe. STB is the strobe. Okay. So it will say, okay, I'm sending a data, and the strobes, it will strobe. That means it is strobing. It is placing a data and it is saying, okay, now I have typed D, say. So I'm placing a data, though D is not a 0 or a 1. Okay, D will be many bits. Okay, it will put one data byte at the input port of the peripheral device and inform. Place one data byte at the input port, and it has informed. So as soon as it is informed, the programmable device will say, it will send another signal, IBF. What is it? Input buffer full. So it will say, okay, wait now, my input buffer is full. I cannot take another bit from you. So the device will now wait. Now the keyboard will wait, and the programmable interface has one byte with itself. Now the MPU is very fast. So it wants the data. It is always checking. It is always checking whether I have the next data byte. So now what will it do? It will send the interrupt signal. This device will send a interrupt signal. And it will say, okay, now I am ready with the data. Now I am ready with the data. Okay? And the MPU will happily come and now read. It will read the data now. So if you have to input, then these signals are required. First, a strobe signal. And in return to the strobe signal, it will say, okay, now the internet buffer, input buffer is full, IBF. So once the input buffer is full, it will interrupt the MPU and say, okay, now I am ready with the data. So the MPU will go and read the data. Okay, so that is how this whole operation will go on. And also there are data lines. Okay, here data lines are there. So the data will be transferred through the data lines. And here the other system buses, address bus, data bus, and all those buses are here. This much is clear. So handshaking with the, that how we are doing a data input. Okay, from the peripheral to the MPU when we are using a handshake signal. So then how we will do data output with a handshake? Again, we will have our MPU. We are having the programmable device, programmable interface, and we are having our peripheral. Okay. So we are seeing data output with handshake. So when we are doing data output with handshake, the microprocessor is giving the data. So the first will be microprocessor will write.
Ma'am, the previous one was data input with handshake, right?
Yes, yes, it was data input. This is the first is it will write. The first step is will write a byte at the output port. Will write a byte at the output port. Okay. Then the device informs the peripheral. Okay. Now this programmable device is telling. Now the programmable device has a data here. Okay. The programmable device is telling that my output buffer is full. My output buffer is full. So it is letting the peripheral know that, okay, now I have something to give you. So the peripheral is saying, okay, I acknowledge that you have a data byte. I acknowledge that you have a data byte. Okay. And it is taking the data byte. And then this peripheral device is again going and interrupting and saying, okay, now I'm ready. So again, the MPU will send a byte. Okay. So these are the device, these are the signals that you will need. The acknowledge, the output buffer full, and the write signal. Okay. And here there are data lines like in the previous data lines, and the system buses are here. Other lines connecting them are here. Okay. The system bus is there. So this is clear. So first you need a write signal. You are writing a write signal. Then you are saying, okay, my buffer is full. So it is saying, okay, now I acknowledge. And then here it is sending the programmable device will interrupt. It's asking MPU for the next byte. Okay, so you now see interrupts we have studied. So we were thinking why we need an interrupt. See, we need an interrupt. Now here in the output, this peripheral can be a printer or a monitor, okay? Because it is giving output. So it has to be output device. So the peripheral can be a printer, it can be a monitor, anything it can be. So that is how it will go, one after the other. Hope this much is clear.
Here, why interrupt is required?
Otherwise, how will the microprocessor know that the data has been read and when to send the new data, next data?
Okay.
So the interface will say, okay, now all this, my job with the printer is over. I am ready. My output buffer is no more full. So you send me. Okay. So then the microprocessor will send. Okay. So now we will go back to mode 1. Just a second. Now we will go back to mode 1. Mode 0 we had seen, mode 1. Now mode 1 is, what is mode 1? The first point is two ports A and B function as 8-bit input output port. Port A and port B are 8-bit input output port. So we know how to put it as an input or an output port. Okay, they can be configured like that. And each port uses 3 lines from port C. Each A and B uses 3 lines from port C for handshake signals. Okay, so for handshaking purpose, A uses 3 lines of port C and B uses 3 lines of port C. So 6 lines are gone. Okay, so the other 2 can be programmed as simple input output lines of port C, the remaining 2. Okay, the input output data is latched. Input output data is latched. And the fourth is interrupt logic is supported. Now we know that we need an interrupt also. Interrupt logic is supported. So then how is this done? Okay, so we will see that input, mode 1 input. Okay, mode 1 in input control signals. We have studied, we just now saw, we will just briefly see, you will understand. So how is it? Now, though I am drawing only the 8255 here, you know that here there is a MPU and here there is a peripheral. Okay, so that we know now. Okay, so this is my 8255A. So here I have so these are being used as the input output port. And I also said that 2 lines, you remember here, PC6 and PC7. These 2 are also used for the input output function, because 3 is used for A and 3 is used for B. So 6 are gone. Only 2 are remaining. So those 2 lines are also used for the input output function. Now I will put port B here and port A on top.
আরেকবার বলবেন ম্যাম
আরেকবার
টিভি
বলবো আরেকবার বলবো Okay, port A and port B are 8-bit input port. So port A is 0 to 7 input port, B is 0 to 7 input port. Port C also has 8 lines. So 3 from that is used for A and another 3 is used for B. So 6 lines are gone. So you have only PC6 and PC7 remaining, which is also used as input output port. These input output lines. 2 lines are remaining, no, from that 8. So that is also used for the input output port. See, now I have PC0. What I am using? I am using for INTR, B. Interrupting B. Okay. PC1. I am saying input buffer full for B. and PC2, I'm saying what is the signal? Strobe. Clear? So if this B has to, if this B, say this is for the B part, this is, I'm designing it for the B. So first the peripheral will give a strobe, then it will say, okay, my input buffer is full. Sorry, I'm saying only internet. Input buffer is full. Then it will interrupt and they will read. The microprocessor will read. You can compare it with that, this thing. What did I write? Here, first we were giving a strobe, then we were giving a input buffer full, then we were giving interrupt and read, correct? In that handshaking. Here also we have that same set of signal. We have strobe for B. This B is for the port B. We have input buffer full for B. We have interrupt for B, and there is a read signal. So the microprocessor is reading, MPU is reading. Okay. And here what we have on top, PC3. So this is your interrupt signal for it. Okay, just PC5. This is your input buffer full for A, and PC6. This is your strobe for A. Correct? So here we are having these three handshake signals for it. These three are handshake for port A, and these three are handshake for port B. So 3 lines from C are used for handshaking signals of port B, and 3 lines of C are used for handshaking signals of port A. Whereas this is as an input or output. Port A is used as input output, and port B is also used as an input or output port.
ম্যাম
Hmm.
ওইখানে মানে স্ট্রোব এর জায়গাটা ওটা PC5 হবে না? কারণ PC6 তো আমরা নিচে ইউজ করছি।
Exactly. Okay. 0, 1, 2, 3, 4. 4 is this. This is 4. Sorry. This is 5. Okay. 3, 4, 5. Pin 4. PC4 is used for the strobe signal, and 5 is used for the internet buffer full signal. Okay. So now you can write what is a strobe. We have discussed what is the strobe signal. This is the strobe input. What is this strobe doing? It is saying that, okay, I have transmitted the data byte. It is saying, okay, transmitted data byte. Then what is my IBF doing? Input buffer full. What it is saying? It is saying that, okay, the input has received the data. Okay, the input has received the data. Input has received data. Don't send anymore. Okay, and when it is reset, after that whole operation takes place, everything will be reset. So then again the new cycle will start. INTR interrupt. Okay, this is my interrupt request. So it will send that interrupt request to the microprocessor, and the microprocessor then will read the data. Okay, MPU will read data. Okay, there is one small thing.
PC6 আর PC7 টা আরেকবার বলবেন কি করে?
Port A has eight lines. Okay, port B has 8 lines, and port C has 8 lines of the. Okay, here you see in this C0 to C7, P are 8, and C is also 8. Okay, in that 40 pins, 24 pins were only for this purpose. Okay, 8255. So here 8 the PA0 to PA7 all are input output. PB0 to PB7 all are input output. Now 3 lines 0, PC0, PC1, PC2 is used for handshake signal of port B. Okay. 0, 1, 2, 3, 4, 5 is used for the handshake signal of port A. So 7 and 8, 6 and 7 are remaining. Okay, PC6 and PC7 are remaining. We have not yet used them. So we can use them as simple input output lines.
Okay, ma'am.
Those 2 lines can be kept as simple input output lines. So that you know that what will you do with those 2 lines? You have to keep them as simple input output lines, right?
Understood, ma'am.
So if you need, you can use them. If you don't need, you don't use them basically. Okay. So they don't have any other function. So there is one more signal, which is the INTE signal here. You will find another signal, that is the INTE. Okay, there is INTE A, they will say, and INTE B. These two are internal flip-flops. So they are internal. You don't have a pin for those flip-flops here. Okay. But you have another word. So you can change the status word and you can program this internal flip-flop INTE A and INTE B. In addition to a control word, there is a status word. Okay. So the status word will decide the status of the flip-flop. This internal buffer and all these are all basically flip-flops that are available with us. So it will decide the status of those words. So this is correct. This is right. Okay, so now we will have another mode 1 in the output. Mode 1 in the output, this thing. So here again, this is my 8255A. PA0 to PA7. PB0 to PB7. PC6 and PC7. So this is my interrupt B. This is my PC2, which is acknowledge P. And this is my output buffer full B, PC 1. Okay. And here I have interrupt A, PC3, PC6, acknowledge A, and I have 3, sorry, PC3 6. The correct, some correction is needed. PC7. These pins are right. Huh? This output buffer full A, and here it is 4 and 5. PC4. Okay, 5. So the lines are different, okay, where we are connecting for this thing. So this is your handshake for B, and these three, this 3 is your handshake for A, for A. So what are my handshake signal I am requiring, and obviously it will there will be a write signal here. The MPU will first write. Okay, so the MPU will first write, and only then this thing will happen. The process will start. So first the MPU will write. Second, the output buffer full will go. Okay, to the peripheral. Third, acknowledge. ACK is my acknowledge, is coming. Okay, from peripheral to programmable device. And once this whole writing operation takes place, then INTR, which is the interrupt signal, from 8255 to MPU it will go, and it will ask for next byte. Correct? It will ask for the next byte. This much is clear. The same discussion we did for the handshake. And here also we have there are internal flip-flops. There are internal flip-flops. This is not part. Okay, internal flip-flops. Okay. INT. These are internal flip-flops. Okay. So this is in the status word. These are internal, and using the status word we can use. So next class we have to do a control word. We have to study the control words for both and the status word. Okay, whatever we discussed till this is right. So once we discuss this control word and status word, nearly this 8255 is over, and we will start with, I think, the asynchronous. This was till now we were doing the parallel transfer. All the bits were being transferred parallelly. 8 bits, A0, PA0 to PA7. Now we will, after this, we will briefly see how the serially how it is done. Now, till now we were seeing the peripherals that were doing it parallelly, and we will also see the RS232 RS standards, and why the standards are needed and how they help us in data transfer. That is something we will see. Okay, I need one class on Saturday because I want to finish this module and go to your 8066. Okay. Otherwise we are running very late. And how many weeks you are having left for your exam? Final exam. Anybody has idea?
Maybe 6 weeks.
5.
So I cannot. You have 8086. You have microcontroller. So
but
everything is 8086. Again, I'll have to start from the pin configuration. Microcontroller, again, I have to start from pin configuration. Everything that I do.
time is
So
so less, ma'am. It's
it is.
very difficult for us also to
Yes,
grab
I
all.
understand. But then you give me Saturday morning slot. You give me today.
Yeah.
So give me 1.5 hour. I will want to finish this. I thought I will finish it today only, but see, again I could not. My time is over. 1.5 hours. It just goes like that. Okay.
Ma'am,
Ma'am,
अच्छा बोलो चतुर बोलो.
ma'am, it is necessary to attach the college front page, ma'am, because it is not available, ma'am. Shops are closed.
College front page. I don't want college front page, but in 15 minutes after the exam, you give me your this thing answer sheet in the. I will give you my own email address. Okay, my personal email address. There only you email me all your answer sheets. So that much you do. I make a PDF. Whatever PDF you make, just check whether it is clear or not. Okay. Sometimes what happens is it becomes black. Some shade has come while taking the while making a PDF or something. So just check that much that I'm able to read it at least.
ম্যাম আজকে এক্সামে কি শুধু 8086 টাই থাকবে নাকি না
86
8255
নয়,
এটা?
86 তো পড়িনি এখনো।
আচ্ছা 8085 না 8255 ওটা থাকবে?
না 8255 থাকবে না। আমি till
previous class
8255 we just now covered, no? So nothing. Okay.
Means, ma'am,
But
no need of front page, na.
no, I don't need front page, but you give it to me on time and try to do it yourself. Don't see from here and there.
Okay, ma'am.
Okay.
yes ma'am
Okay. Okay. Aniruddha Saha, Anamika Rai, Anubhav Malo, Anubha Malo.
Yes, ma'am. Anamika Rai.
Anamika
Yes,
Rai.
ma'am. Anubha Malo.
Aurobindo Parai,
Yes, ma'am.
Ashutosh Kumar, Dipanesh Das, Himanshu Kumar,
Yes, ma'am.
Himanshu Kumar, if you
Yes, ma'am.
Himanshu Kumar, okay. Jyotish Ranjan Mollik,
Yes, ma'am.
Kumar Chatur Ranjan,
Yes, ma'am.
Modhumay Bhattacharjee, Mahiraj,
Yes, ma'am. Yes, ma'am.
Mohammad Nawaz Rahman,
Yes, ma'am.
Medha Bashunia,
Yes, ma'am. Present, ma'am.
okay. Megha Sarkar,
Present, ma'am.
Pallavi Singho,
Yes, ma'am.
Polumi Rai,
Yes, ma'am.
Polumi Singho,
Ma'am,
Present, ma'am.
58 Dipanesh Das.
okay. Prince Kumar,
Yes, ma'am.
Priyobroto,
Yes, ma'am.
Noskor,
Yes, ma'am.
Rahul Gupta,
yes ma'am
Ravi Prakash,
Yes, ma'am.
Ruma Hasda,
Yes, ma'am.
Rumki Mukherjee,
Yes, ma'am.
Yes, ma'am. Rumki Mukherjee.
Sagar Noskor,
Yes, ma'am.
Shamanita Banerjee,
Yes, ma'am.
Ragni Koja,
Yes, ma'am.
Shiv Mahato,
yes ma'am
Shrimoy Shaha,
Yes, ma'am.
Shubham Kumar, Shoma Sen.
Yes, ma'am. Samya Sen.
Okay. Shomadip Datta.
Yes,
Saurabh
ma'am.
Das. Saurabh Das.
Present, ma'am. Saurav Das present.
Shubhashri Datta.
Present, ma'am.
Charupa Das.
Yes, ma'am.
Tanmay Ghosh. Vijay Kumar.
Yes, ma'am. Vijay Kumar.
Wasim Iqbal. Wasim
Yes,
Iqbal.
ma'am. Yes,
Okay.
ma'am.
Okay. Wasim Iqbal.
Ma'am,
is it from
Ashutosh Kumar.
Ashutosh Kumar. Okay. Okay. So 230.
Aniruddha Shah.
215. Aniruddha Shaha. Okay. Aniruddha Shaha.
Ma'am, Rumki Mukherjee.
Rumki Mukherjee. Okay. Done. Okay. What I'm saying is 230, 215. I will give you the question paper, right? So I've asked you CR to. Bolo?
Saurav Das, ma'am. Can you please take?
Saurabh. Okay. Saurabh Das. Okay. Acha.
Ma'am,
So
अगली
I have,
क्वेश्चन मैम.
okay. I have asked your CR to add me to your Facebook group, WhatsApp group. Okay. Around 210 to 14, you add me. 215, I will give you the paper. And after the exams are over, if I will remove myself, and even if I don't remove myself, remove me, okay, from the group. So,
Okay.
Ma'am,
bolo.
ma'am, on
Ma'am, what is the
Saturday.
time of submission?
One at a time, please.
Ma'am, what is the time of submission?
15 minutes after your 1 hour paper, and 15 minutes you take after your this thing. How many
Okay.
pages? 2-3 pages. It will be what? Okay. Write your name and roll number. Your full roll number you write. That you write in the exam. That roll number only you write.
Ma'am, on Saturday morning we have exams, so we have to do the class in afternoon or something like that.
Okay. So any other time you are having free, you tell your CR to tell me.
Okay, ma'am.
Okay.
Okay. Okay. Just check and tell. Okay. Thank you.
And ma'am, I need to.
Bus. Okay.